Sweet. All right. Well, welcome everyone. Like to introduce Ashley here as well as Darius. They're our two Modine mentors, and we'll kind of be talking with Ashley today on kind of her role as a electrical engineer at Modine, her kind of daily tasks. She'll obviously kind of go into a little bit more about herself, her background, and kind of what she does at Modine. And yeah, she prepared a little presentation, so we'll get that from her. But I'll kind of leave it up to her and introduce Ashley. Once again, thank you for coming and take it away.
Yeah, so first I have to figure out how Google works with presenting because this is not something I have done before.
All good. There's like a little box with an arrow in it, and it should say present now. And then I think you hit your entire screen.
All right, we will try that then.
Awesome, can see it.
Sweet. All right. So hello, I am Ashley. I'm an electrical engineer here at Modine, and nothing is actually on my computer where I want it to be. This is fine. Nope, I don't get to see any of you apparently. This is completely taken over my screen. But hello, I'm an electrical engineer and apparently technologically incompetent, but that's all right. I joined Modine in March this past year, so I've been here for about 3 months now, and I love it so far. I went to MSOE, which is Milwaukee School of Engineering here in Milwaukee, Wisconsin, and I graduated in 22 with an electrical engineering degree. During my time there, I had 2 internships, one at Medtronic, which was my first summer after getting into college, so it was that freshman summer in the Medtronic metrology department, which is just a really fancy way of saying we calibrated things, keeping things, reading the correct numbers and reporting the correct numbers. My second internship was at Zern, which is a water processing company. They do a lot of things with piping and valves, as well as faucets, bathrooms, that kind of a thing. I was in their new product development department, and I started right before COVID hit, so we went online immediately, which was a really interesting thing. Then after I graduated, I had a contract position at GE Healthcare, also in the new product development department. So I hope you're seeing a theme right there. I do like doing new things. So here at Modine, we do a lot of the e-mobility in our department. So a couple of things that make it very unique is the automotive requirements, the standards, and the things that we just basically have to read and conform to their industry-wide standards. So the things that I hear mentioned a lot recently are these 3 standards: ISO 16750-2, which specifies some electrical tests for us. So when we're designing our components, we just have to make sure that we're designing to pass these tests at the level or the classification that we're looking to pass them at. ISO 26262, which is very fun to say, is functional safety. I'll touch on that a little bit later. And then ISO 21434, which is cybersecurity. And they're just ones that, when I'm asked, hey, what standards are you working with right now? It's these ones. It's always these ones. These ones are just the ones that pop up the most. Another thing that makes Modine here unique is we're working with high voltage and low voltage systems. So anywhere from 0 to 1,000 volts for the high voltage, and your wall is 120. So very high voltage. And then our low voltage system is 0 to 45. And we often put these on the same board, the same PCB, and we have to, engineer some safety controls into that and make sure that we're not going to have high voltage where high voltage should not be. And then Modine's goal is engineering a cleaner, healthier world. And right now we're doing that by moving into the EV sector. Here, the physical building itself is also pretty special. We've got a wind tunnel and then some thermal test chambers, so we can bring in these giant semis and, the backhoe combos there and do some actual wind tunnel testing, environmental testing with them, because those lamps you see on the side actually simulate the sun, which is really kind of a neat thing. We also have, for our department, the Advanced Thermal Solutions Lab, the ATS lab. It's getting a revamp and remodel here, and we're getting a whole bunch of new test bench setups, soldering equipment. It's really quite fancy up there now. And then this building that here in Racine also boasts the sample shop, which is responsible for sending out those like one-off customer requests of like, hey, can we have 6 of that thing to validate and do some design with. With that sample shop, Modine is a tier 1 supplier, so we've got a variety of customer needs, a variety of requirements that a variety of the customers are asking us to do. So that 26262 requirement is something that the industry is moving towards. So a lot of the customers have been asking us for various aspects of that ISO 262 requirement. 26262, so many twos. So in doing that, we get to be a developer of unique and very innovative solutions to a lot of the problems that these customers are having.
So I got a quick question, and then just
Yeah.
I wanted to say, if anyone has a question, feel free to drop it in the chat or raise your hand. But in terms of those awesome labs that you guys have that look really big and expensive, do you get to kind of like do some of the testing, or is it more so you guys have like test engineers that navigate those for you?
It's some of both. It really depends on like the level of the test. So I'm not certified to use any of our vibration plates. So if I wanted a test done on one of those vibration plates, I would have to fill out a work order and give them the test and give them instructions on what I needed done and that kind of a thing. Whereas there's smaller things, and it'll be up here. I think it's on the slide right now. That little PCB down on the bottom, I'm actively doing testing on at my desk. So it depends on like the scope of the test.
Yeah, makes sense. Sweet, thank you.
Yeah. So with that, my typical day can involve testing, and right now it involves a lot of trial and error testing with some firmware development. Because there's a variety of projects that I'll be working on at any given point in time. So with any of those projects, there could be some hardware development, firmware development, a meeting to go to, or some simulations that I'm running and trying to get some answers on a very particular problem for. So with all of the things that I'm up to, I've got a lot of flexibility working at Modine here. I can work from my desk, which is up there in that picture, and where I am right now. I can work up in our ATS lab, which is where I assembled all of these little boards that you saw on that other slide. I can also work from home if I'm not doing anything that needs to be particularly like hands-on and working with lab equipment. So sometimes I'll be from home doing firmware development or reading a lot of data sheets, that kind of a thing. With that, there's also some pretty flexible hours here. I guess the base requirement is do your 40 hours, which is really nice, which means that if you've done your 40 hours and it's 2 o'clock on Friday, please go home. We love you, go home. You're contracted for 40 hours, please go home, which is really nice and a great environment here to be at. The other thing that I'm loving is that on Mondays, I do some laser sailing. That was in that very first slide, me on a boat. And I've been able to get like every other Monday here during the summer to be able to go and do some sailing, which is just wonderful. The other thing that the team here is really, really great about is answering questions that are asked and not like giving you a runaround on, oh, I don't know how to do that thing. Like they're going to help you solve your problem, and they're going to give you the resources further to help you solve your problem. And one of those resources is that picture there, which is our Stack Overflow. If you've used Stack Overflow, you know how it works for like electronics or code. type in a question, somebody's probably had it before, you get an answer. And that's sort of the goal with our internal Stack Overflow. So a couple of the projects that I've been on, this one is complete and is actually in a couple of our schematics. It's for measuring negative voltage. So this is our high voltage negative measurement circuit, meaning we've got that 1,000 volts, or in the case of negative, we've got a negative 1,000 volts. And the trick to it is trying to measure it and report that there's a negative voltage, because that will allow us to inform the customer if they've plugged terminals into a connector backwards, because it's super easy to do. It's also very unique within the industry because nobody else is doing this right now. They just are like, error. They don't tell you that, oh, it's because you plugged your terminals in wrong. So this ran through design, simulation, testing, and then a lot of documentation through all of those steps. Because we looked at these things and we're like, how can we measure this voltage and not have it blow up our microcontroller? How can we drop it down from 1,000 volts to 3.3? That's those giant 1 mega ohm resistors that are in the center there. Then we ran some simulations. We weren't entirely convinced that it would actually work the way that we thought it would. We were still pretty convinced it was going to blow something up, actually. So we built a test board. We ran all the tests on it, documented it, which is that graph there you can see on either side of 0, the negative 1,000, and positive 1,000. And, oh, I'm seeing that is there, right. And we were able to prove that this did actually work, and it was safe, and we could use it. So it's now in a lot of our schematics that are using high voltage, and that we are going to be reporting on a inverted terminal. So that was a complete project. There's bits and pieces that I do in a lot of other projects. So one of them is hardware component selection. And that's anything that goes on the schematic, on the PCB, that needs to be basically validated in order to ensure that that particular component both does what we want it to do and meets some further specifications, like being automotive qualified. So doing some research into different parts. So right here on the screen is the isolator research I was doing. And the isolators serve as a barrier between the high voltage and the low voltage side and allow us to pass signals back and forth without having to actually have like direct lines on a trace or a trace on a PCB going across. We can run everything through this chip and it keeps it a lot safer and it gives us an isolation barrier. But finding these chips was a lot of work, and I'm a very visual person, so I was able to lay this all out in Excel, which is that bottom section there, and track how many signals going from like the high to the low that I needed and how many going from low to high that I needed. With component selection, there's also other things that we do, like power consumption calculation and trying to optimize for cost per build. The other thing I'm doing with hardware is doing some PCB modifications for our application engineers and hardware engineers as they go to assemble things and they have ideas on how to make something either easier to assemble or another way to like cut down on size. So right here, there's that very bottom of the board, right where it says Modine Manufacturing. There's a little notch in. That was the most recent update to this particular board, and it was to make it a little bit easier to get everything soldered in once this was mounted. But yeah, slimming down on a PCB also saves on space and weight, which are at a premium in the automotive industry. I mentioned simulation before with that negative voltage circuit. So this is something that I'm doing currently and working on some code for right now. So all the simulation's done and all the math is done, and now it's just making it work on the board. But the simulation for it was what proved that this can actually work. So here's all of the requirements that I was given. I had to design a way to read an external resistance to determine like a customer selected value, essentially. So we had to read that resistor. Had to maximize the number of possible addresses, use some standard values for the customer provided resistor, and tolerate a 32 volt input. The MCU, again, can only read 3.3, so figuring out a safe way to drop that down and be able to report on what address was being actually desired was a pretty fun challenge here. Ended up with 10 addresses there you can see in that blue table. And then the circuit is up above, and that's an LT Spice simulation that I was using to do some worst case or like Monte Carlo simulations that would just tell me if anything overlapped in various aspects. But that's one of the more typical things, I guess. I mentioned that I was writing some firmware for it right now. Those are the ADC calculations. They involve a lot of low-level driver development, datasheet reading to find that register that you're looking for, to change that one bit that you're looking for, and then writing all of this code for readability and reuse, because this isn't going to be a one-off thing. We're going to use that CAN address selection in a lot of different devices. So making sure that this is modular and can be used again and again is super important.
What are some of the, I guess, tips and tricks for having that modular style of programming?
Making things rather general, so like using your defines and then using that define to actually set the value you're looking for, and then having that define that variable be the thing that's through everything, so you're only having to change one thing in one location, is a pretty easy way to make it more modular.
Mhm.
It's definitely not the only way, but it's the way that I know and prefer.
Yeah, no, that makes sense, and I'm sure commenting your code too goes a long way.
Yeah, I wouldn't say try and stay away from commenting, but we try and write code to be easily readable without comments. So like there on the very right-hand picture, float get bus voltage.
Mm-hmm.
Well, you're going to be getting the bus voltage and it's returning a float. All right, how do we get the bus voltage? We get the ADC value, which is count. We use count to calculate the bus voltage, and we return VBus as a float. Okay, that makes sense. How do we get the ADC value? Well, we're going to use max. See, this isn't great because what's use max? Use max is defined above, but it's not great. But we're going to get the ADC SPI value with the pin ID that's being passed in, which is VPAT pin. So this right here isn't the most readable. It's getting there, but it's not perfect.
Awesome.
So speaking of getting there but not perfect, the entire industry is moving towards requirement documentation. And that's part of that ISO 26262 functional safety requirements. So being able to track requirements and being able to document any changes, that type of a thing, is becoming super important to our industry. So we are using a system called Polarian, and it's just a systems engineering process. Well, the software is Polarian. The process is systems engineering. To document all of our electrical and firmware requirements before we're starting on a new project. So we're in that documentation process and the approval process and making sure we've got, all of our T's crossed and I's dotted before we start firmware development. And
Sweet.
again, the whole industry is moving towards it, so Modine is just trying to be on that leading edge.
Yeah, totally understand. We got a question here from Samuel. What program language is being used? I assume C++.
Yeah.
Look like
Yep.
C++. And just for a little bit more on that, what's your background in programming? Did you take a specific C++ class? Were you kind of just doing it on your own?
Yeah, MSOE is rather special in that way with their electrical engineering program. They put us through a 3-course embedded program where they teach us C languages, and then like the final capstone of that 3-course series is building a little mini robot and programming it. So MSOE is rather unique in the sense of they rolled it all into our curriculum, but
Okay.
it was just an embedded development class.
Sweet.
But yeah, so I guess unsolicited internship advice. If you know something that you're interested in, whether it's a particular company or a particular variety of thing, like for me, it was the new product development. I would apply to all of the roles that were like, oh, this is a new product development internship. This is an R&D internship. Things that were doing things aligned with what I was looking for and things that I knew interested me. It was what I was applying to. Obviously, that didn't work out my first, freshman summer, and I ended up in a metrology department. I learned a lot, but it was only a summer, and I knew I didn't want to do metrology after that. So you'll learn a lot from an internship, even if it's not exactly what you're looking for. Keep your resume updated. Include everything that's relevant to that job that you're trying to apply for. And then just keep applying. Start early. A lot of places are, hiring by November, by December, and a lot of places also aren't. That Medtronic one I got in March. So there's a lot of places with a lot of different deadlines. Stay on top of them. A lot of them are like, hey, here's a giant program that your application is being put into a pool with everybody else. Submit your resume by, January 17th or something. Keep track of those random dates.
Mm-hmm. Mm-hmm.
And then networking is super important, but not for the and here's a job tailor fit for you reasons. We're expanding, like seeing what's out there, reaching out to, your mom's friend's nephew, that one cousin down the block type of a thing. People who that might be in the industry that you're looking to be in are super helpful in just terms of, well, how do I tailor my resume to be more applicable to this thing I'm looking for? That type of a thing. And then from the interns here, these are their recommendations. Leverage your college projects. That one that you hated, but does actually apply for the thing you're looking to do, it's now your favorite thing. Take classes that interest you. So if you're looking for that C++, C language class, take that. If you can't get into it, this is my advice. If you can't get into it, take a class that you're never going to actually seek out on your own, but that is still relevant because, I don't know, I never wanted to know the inner workings of a special electric motor, and yet I took a specialty electric motor class. And now I'm here at Modine working on specialty electric motors. So never thought it would be applicable. Super happy I took it. If you've got small projects you're working on, those can also go on your resume. Would highly recommend putting them on your resume, actually, especially if they're projects that you're interested in, which if you're doing in your personal time, I would kind of think that you'd be interested in that particular project. And then the interns here also recommended researching the company you're going to interview at, asking them the hard questions about, the company culture and how they would fit on the team and what project they would be doing.
Awesome. Yeah, and I think I remember when Darius was giving this presentation, and over the winter, he couldn't stress enough that personal projects go a long way, maybe even more so than some of your school projects. So really just doing.
Yeah, plants, yeah. I have a meeting. Yeah, me too. What's that? No problem. I'm a pumpkin seed and then, yeah, so it's, staff here.
Is he joining in?
I'm sorry, did you just ask me a question?
No, I was just
Okay.
I was just saying that from the past winter program, you were just stressing how important it was to have those personal projects on your resume and to talk about.
Oh yeah, definitely. Man, that was the worst timing. The one time someone walked by my desk to ask me a question was the one time I had to chime in here. Yeah, definitely. I mean, I look at a lot of resumes for internships, and one of the first things I look for is, are you doing any personal projects and what are you doing? Because first of all, doing personal projects outside of work or outside of school doesn't magically make it like not experience. Like it basically counts as work experience almost. And second, it just shows that you're into what you're doing. And it does indicate that you'd be a motivated intern here.
Yeah, and I think that's a good kind of segue. Ashley, thank you for the presentation. We can kind of jump into like some more kind of Q&A style questions. I got a question here from, oh, perfect, look at that. I got a question here from Adam. Why, or do you choose kind of what projects you work on, or are they also assigned to you?
So far, they've been assigned based on just what's coming up in the pipeline of development and what needs to be done by when and who's available to work on it.
Awesome. Steven, you wanna go?
Sorry, I'm on my iPad. I don't want my face to be jumping around.
All good.
Sorry, I just have a quick question for when you were talking about like personal projects you've done. Like, what experience would you say for like doing an electrical engineering co-op or internship? What kind of experience would you want to see on there? Like, if I build a computer, would you want something like that, or do you want something more related to like fixing automobiles like on your own, or what do you really look for when you're looking at that?
Got nothing on there. Pretty much anything's good. So putting in like a computer build you made, and or maybe I don't know, listing some specs just to show that you're paying attention. Definitely better than nothing. Stuff like working on your car, fixing your car. There's a lot of troubleshooting and stuff we do here. So just having some level of technical proficiency, all of that is great.
And how highlighted do you normally have it? Like, how far up do you think someone should put that in their resume? Like, how important do you feel like that is compared to schooling and the other like projects and stuff you have on your resume from your actual schooling?
Yeah, so in terms of like resume format, the way I tend to like it is you got your name, obviously, contact information, put your school there, and then if you've had prior internships, put that on top, and then personal projects ahead of anything else on there. So behind work experience, but ahead of everything else, and then talk about like school projects, what classes you've taken.
Yeah, and those can also, personal projects can also kind of morph in with club projects because it's a little bit hybrid where it's not necessarily a classroom project, but it's something that you enjoy in your free time so much that you're in a club and you're kind of doing that for. So kind of along the same lines there. Gavin, you want to just ask your question yourself?
Sure. So what has been your favorite project at Modine? Like one that's been like the most interesting to you?
Probably the CAN address selection. It just was so vague to begin with and very open-ended to end up with such like a closed solution answer. Well, here's 10 addresses. I was also asked multiple times during it to, oh, can you adjust for these parameters? Oh, wait, we forgot to account for quiescent current. Can you adjust for that? What about if we add in the 1-volt offset? What does that do to things? So in terms of like breadth of experience there, I thought it was just a wonderful project.
Yeah, it seems like kind of very agile and having to act on your feet, but also free range versus like a school project where everything's laid out and you have to have specific deliverables. Kind of a question to segue off of that. How did you kind of go from your schooling and like your classroom projects to then getting your first internship, kind of excelling in that space? How was that kind of transformation period for you?
Yeah. Let's see. That first internship was at Medtronic and was very much a let's see what's close to home. Let's go back to Minnesota. Let's see what's around. So those were really like my parameters there when I was looking. I went into it hoping to learn something for an internship. And the program that I was in was really neat. They took us around to a whole bunch of different campuses, taught us a whole bunch of different things that wasn't necessarily metrology. There were a whole bunch of other interns doing that same program, so going on tours at different sites, which was really cool. So I just went into it hoping to learn something, anything, and being super excited when I did. I feel like I've half answered that question.
It was I kind of rambled on, and it was probably 5 questions in and of itself, but yeah, kind of along the same lines, internship advice for these students starting your career path. Obviously, you kind of said how you tried a different internship that you ended up just kind of not liking. Do you want to kind of go into that on if you were interested in it previously and then just kind of figured out on the job, or was it something that you knew that you wouldn't like and you still did it?
I had no idea really what metrology was going into it, and that I would be essentially, sitting at a computer calibrating the desktop DMMs and calibrating oscilloscopes. And it was very much a doing the same thing in a slightly different font every day, which I did discover drove me nuts. So I was like, well, I can't do something that is the same every day. I need to have variety in what I'm doing, which is, something that I've found really wonderful about being here.
Yeah, that's another good kind of segue on kind of the overall culture at Modine. How, there are those people who like that kind of narrow-minded, how do I call it, just task assignment where it's the same thing every day, but it seems like at Modine it's kind of something new and different. So do you kind of want to talk a little bit about the culture at Modine and how that kind of plays into why you like it there so much?
Yeah. So our department itself is relatively new, as well as everything in the industry that we're doing is relatively new. So it's a lot of, thinking on your feet and solving the problems as they arise, because you can't really foresee that problem before it gets here. So I like how flexible and how adaptive the whole department is. We were recently focused on one project, and then a customer came in and said, hey, I really need you to be doing this other thing instead. So our entire deadline structure shifted to accommodate that, which was really neat.
That is really neat. Adam, you wanna ask your question? I don't know if we can. I think I heard you for a second, but still on the call. Otherwise, I'll just ask it. So from Adam here, how often do you get the opportunity to work with other engineers? Do you only work with electrical engineers or other disciplines? Kind of what's the cross functionality in terms of teamwork at Modine?
Yeah, it's very cross-functional, especially as we're doing our requirement development. We've got, the rest of the EE team here, so Darius and Samuel in on these meetings. We've got a couple of our interns coming in with their experience and what projects they're working on to contribute to the requirements. One of the interns is basically running all of the requirement documentation as the systems engineer, which is cool. So every day you get to talk with the rest of the team every day.
In terms of do you work with any let's say project leaders where they're not necessarily as hands-on, or like a marketing team who had any kind of non-engineering focused people as well?
The answer there is definitely yes. Those are the meetings that I attend that I'm just sort of there to answer questions about how something is coming. So there are cadence meetings, and are they project managers?
Yeah, Chris Trees would be one of our product managers.
Gotcha. Yeah, so they kind of just are checkup meetings, see if you guys are on schedule or not. Makes sense. All All right, we got like about 10 minutes left here. Anyone else? Sweet. Charles, go ahead.
So I guess, are there any skills that you learn outside of classes or that you pick up in clubs or in your own personal time that you would recommend other electrical engineers?
Definitely. I was in a couple of different clubs at MSOE, and the biggest takeaway that I got from all of them was learning how to communicate on a cross-functional team. So on the robotics team I was a part of, we all became rather siloed, and the electricals would be overdoing something, controls would be in a back room with a variety of Ethernet cables, and we had no idea what they were doing. And then mechanical was over there, I don't know, drilling rivets out of things, and nobody really knew what was happening to begin with. So there was a major cultural shift on the team itself, where we integrated cross-functionally. So by far the biggest takeaway I've got from clubs is learning how to work in a cross-functional environment and learning how to communicate different things that are needed from different teams and how to align all of those deadlines.
Yeah, it's a really important skill that, at least when I was a ME in school, it was classes with all MEs, so you never really get that cross functionality. So I think clubs is a great way to get that. I kind of going back to the kind of internship experience. What sort of kind of methods, or I guess, how did you make an impression to your previous internships? Like, how do you find out if you actually like it? How do you get involved enough to where you know that you want to work there? What does that sort of barrier to entry look like?
Yeah, so my internship at Zern started off, right before that pandemic hit. So I think I was in the office getting to know the team for about 3 weeks before things really chaotically took off and everybody was sent home. So that was like my biggest introduction to how the team handled chaos and adversity and how they reacted, which was setting up whole new methods of keeping in contact and doing testing and arranging for safeguarding of their teammates, basically, because we all had to be doing some testing in the lab at some point, and we're like, well, how can we manage that safely? So I learn a lot by observing and asking questions. So finding somewhere that was, open to me basically being like, I'm gonna watch for a hot minute and then I'm going to ask questions and I'll get a really good understanding about what's happening just from that. Was super important to me. So when I, interviewed here, I think I'm fairly certain I asked how, like how okay are questions? How does the team function? That kind of a thing. So finding the things that are important to you on a team and then remembering to ask about those in an interview.
That's a good tip. People love questions. They love curious minds. So I think that's a good point to hammer home there. Anyone else? Any questions? Let's see. I'm trying to think of another one. Carter, go for it.
Yeah, I was just gonna ask, if do you have any controls engineers, or is it mainly just focused on like purely electrical? I guess, or would you consider like this working with CAN signals kind of part of that?
I'm gonna go with, I'm not entirely certain as to the job title, but there are definitely people here that do way more in-depth firmware and the controls engineering of things than I do. I'm far more hardware focused.
Okay, yeah, thanks.
Yeah, we call those embedded systems engineers, and they focus pretty much all their time on firmware.
Okay.
Good question. Steven, go ahead.
I'm not sure if you've covered this, but how does the internship side of the Modine differ from the normal 9 to 5 job side? I guess I would say.
Good question.
Jump in here. So we generally like to treat our interns just like they're full-time engineers. They actually get some more perks than we do in some ways. They've got these intern events every few weeks, at least during the summer. I think next week they've actually got a pizza party and golf outing planned, which I don't have for my full-time engineers right now, unfortunately. Maybe soon. But yeah, I mean, we give them pretty similar tasks as full-time engineers, just keeping in mind their level of experience and how long they're expected to stay with the company, obviously. Thing we actually offer interns that we don't offer full-time engineers is a housing stipend. We give them a certain amount of money per month, and there's some student housing that we have a partnership with that's south of us, so that they can get either free or heavily subsidized housing while they work here.
Sounds like some great perks. Samuel, you want to go ahead?
Yes. So one of my question is, what is one major project that the company is currently collectively working towards? Or should I say a goal?
So my team, we do new product development, meaning we develop new products. So the big goals we're working towards tend to be focused on those individual products. Currently, we are working on a component, a valve actually, which doesn't sound very exciting, but it's actually going to be the very first valve or can controlled valve on the electric vehicle market. So we're really leading the industry in vehicle valves, I guess. Other than that, as a company as a whole, we take our whole tagline of engineering a cleaner, healthier world very seriously. So we're focused on things that really either help decarbonize the world or help make just a better environment for people, whether that's enabling electric vehicles or like home and business and school products that help clean the air and just make the environment nicer for people to work in.
Excellent. What about the valve aspect? So what precise valve is that, and what part of the electric vehicle does that work with, or does it resonate, if I may say?
That's a coolant valve. So one of the big products we sell is a battery thermal management system for electric vehicles. And that goes through this whole refrigerant loop. It does passive and active cooling. And as part of that, it pumps coolant through various components within the cooling or heating loop. And the valve is meant to switch between different operating modes in that loop. So we can switch between either an active or passive heating and cooling mode using the valve.
Thank you.
Thanks for the questions. Those are great.
Yeah, those are good. All right, we're coming up on 2:45 here. Any last final questions from our cohort to the Modine team here? Awesome. And they'll be available. I'll have their contact information if you ever want to get in touch with them to kind of ask some more questions if you ever think of any. But yeah, I'd like to just say thank you again to Ashley and Darius for taking some time out of their day to give this presentation and kind of explain Modine and kind of why it's such a front end innovation company. So thank you guys. And if there's nothing left, have a great rest of your Thursday.
Yeah, thank you. It
Yeah,
was great
thank
talking
you.
to you all.
Yeah, awesome. Thanks, everyone.